Hello everyone. So in today's class we will learn pre-expansion, cyclic and non-cyclic process. So first of all, let's learn pre-expansion. So how gas expands freely and what is work done, internal energy and heat supplied in this free expansion, we have to see with one example, right? So what I am doing, see, I am taking two chambers. Let me draw the diagram first and then you can draw yourself. So there are two chambers I have taken. These two chambers are there. So in this first chamber, I am keeping gas. What is in this chamber? Gas. And here is a stop cock. Okay. Stop cock means just like a wall. Okay, just like a wall. And in this chamber, there is a vacuum. What is here? Vacuum. And this one, this is totally insulated. This chamber is insulated, means there is no contact between surrounding and this system. Here, understand now what I have done here. So in this first chamber, I have taken gas, and this one is insulated. So if you want, you can shade this part. Okay, so that it is insulated. Okay, which is insulated. first point here, you see this free expansion is adiabatic process. Free expansion is adiabatic process. Why it is adiabatic process? Because or in which work is performed, no work is performed, we can say, in which no work is performed on or by the system. On or by the system. Understand? Now, see here, when stopcock is opened, when stopcock is opened, what will happen? This gas will rush into this chamber. Gas will rush into evacuated chamber. Yes or not? This is gas and this suddenly it will start coming into this chamber which is evacuated. Evacuated vessel also you can say, or chamber. Evacuated vessel and expands freely. Yes, because here is vacuum, so gas has so much space to expand. Now, in this process, what is happening? See here, in this delta W is equal to 0 because walls are rigid. Because walls are rigid, so no work done. Next one, delta Q is equal to 0. Heat supplied is also equal to 0. Why? Because walls are insulated, so there is no heat exchange. Walls are insulated, right? Next, delta U. Delta U is also equal to 0 because delta Q and delta W are 0. That's what this is called free expansion. See, so whenever there is no work done, there is no heat change or no internal energy, then we can say that it is a free expansion. And this is what one example we have taken for free expansion. Yes, so note down. Okay, finished. So let's move ahead. Next, now cyclic and non-cyclic process. They are asking 2 marks question for this or on this topic. What is cyclic and non-cyclic processes? So you should able to define that. Cyclic and non-cyclic process. Cyclic and non-cyclic process. So first one, what is cyclic process? Or point wise I will give you better, because as we have given heading cyclic and non-cyclic process. So first point, cyclic process consists of a series of changes which return the system which return the system back to its initial state. A cyclic process consists of a series of changes which return the system back to its initial state. Means this is like one cycle, complete cycle. Again, same states it will follow. From one state to another state, again from second state to first state, like that. Continuous things are going on happening, right? That is what cyclic process is. In its name itself, it suggests what will be the cyclic process, right? Next one, what is this non-cyclic process? You see, so obviously how it is, it's reverse, yes or not? So in non-cyclic process, in non-cyclic process, in non-cyclic process, the series of changes the series of changes involved do not return the system, do not return the system back to its initial state. Isn't it? Very simple. Back to its initial state. Okay. Next one, see next point. In cyclic process, in cyclic process, delta U is equal to 0 and delta T is equal to 0. That is what temperature of system remains constant. Is there any change in the temperature? No, that's why temperature of system remains constant. In which process? Cyclic process. So as this delta U is equal to 0, so therefore delta Q is equal to delta U plus delta W, and therefore delta Q is equal to delta W in this case. Therefore, heat supplied in cyclic process, heat supplied is equal to the work done. Right. So in a cyclic process, what I told, this internal energy, change in internal energy is equal to 0, as well as if change in internal energy is 0, obviously there is no change in temperature. Therefore, delta T is equal to 0. If we will use first law of thermodynamics, just substitute this delta U is equal to 0. And then if we will substitute this delta U is equal to 0, then this term is going to be vanish, and delta Q is equal to delta W, that is heat supplied is equal to work done in the cyclic process. Okay, next one, next point I'm writing, for cyclic process, for cyclic process, PV graph is a closed curve. PV graph PV graph is closed curve, and area enclosed area enclosed area enclosed gives the worker. Area enclosed by the closed path gives work done. Wait, let me give you one diagram also. Before going forward, I want to write this one note point, but I will give below the graph. So wait, here you see now, this is a PV graph I am showing you. I am taking rectangle, square, or even circle also, whatever it may be. Okay, it may be circle, it may be what we can say. If you want, I will give one more diagram also. It may be circle, it may be square, whatever you want, but it should be just cycle. Sometimes it may be like this circle also. So now I'm giving some names. A, this is B, obviously this side is P, and here is V, because all are PV graphs. Here also this is P, pressure on this y-axis, volume on this x-axis. Okay, this side also P. And now A, B, C, D, and this is like this direction. You see, direction. You see, direction. This is clockwise, and here I am taking anti-clockwise. A, B, C, and D. Here also I am taking clockwise, and this one I am taking anti-clockwise. It may be a rectangle, it may be square, or whatever it is. So this is very important. Clockwise is positive work. Positive. This is negative. Here is positive. Here is negative. Negative work. Here also negative work. Positive work. Here also positive work. What it means? It means that you see in this box, I'm writing what is that? Important this one is cycle is clockwise. Cycle is clockwise. Work done is positive. Okay. And second one, cycle is anti-clockwise. Work done is negative. Keep it in mind. Cycle is clockwise, work done is positive. Cycle is anti-clockwise, work done is negative. So this one you have to keep it in mind. And area bounded, already I told you. Area enclosed by this closed path gives the work done. Okay. So note down this. Note down this and try to understand. If you have doubt, just call me. Okay. Okay. Let's move ahead. Next. Now this we have finished about the cyclic process. What about non-cyclic process? So work done in non-cyclic process depends upon the path chosen. Depends upon the path chosen. Or the series of changes involved. Or series of changes involved. And can be calculated by the area covered between the curve and volume axis on PV diagram. Between the curve and volume axis on PV diagram. How it is? Let's see. I'm plotting here one graph. You will get to know how is the work done. Because as this is not a cyclic process, so how it will be? It may be half circle or something like that. So wait, let me finish first. This is A, this is B, and this one is C. Obviously, this side is P, and here is P. Here also this is P, and here is. Is it a cyclic process? No. See, you can see this is not continuation. This is just A to C, B, C. Okay. So here, if you want work done in A, B, C, what you should get this shaded part. But this is also again what clockwise. So this is what positive only. Yes or not? So positive of shaded area. Positive shaded area. This is what work in non-cyclic process. Here also you see, if I want this area of this, so this shaded part, whatever it is. Okay. So W of A, B, C, D, W of A, B, C, D is what? Negative of shaded area. Negative of shaded area. Understand? So here also clockwise and anti-clockwise matters for sign of that negative, or either it is negative or positive, and you have to just take the shaded area. Understand? Okay, so just revise this, note down, and let's stop here. Bye for today.